Guys, welcome back. So this is a question from GATE 2017 on network theory. So consider the circuit shown in the figure. So this is the circuit and they're asking us to find the Thevenin equivalent resistance across P and Q. So these are the terminals PQ and we need to find the Thevenin equivalent resistance across these terminals. So this is again our standard simple question. So the first thing we have to do is, if there are any independent voltage and current sources in the circuit, we have to short the voltage sources and open out the current sources. So here we have one independent voltage source, so we have to short it. Okay, we have shorted. Now if you see, there is also a dependent voltage source. We should not short this dependent voltage source. Only the independent sources we have to short and open. So if you did not have this dependent voltage source, you could have just simplified this R ladder, R network, right? So it will be like 1 ohm in series with 1 ohm, which will be 2 ohm, which comes in parallel with your another 1 ohm. So your looking RTH will be just 2 by 3 ohms. But now this 3IO dependent voltage source is also there. So then what you have to do is, you can either connect a voltage source of 1 volt and find the current I. In that case, what will be your RTH? Your RTH will be 1 by I, right? Or other thing to do is, you can connect a current source of 1 ampere and then you measure the voltage across this. So let's say this is V, then your RTH becomes 1 by V, right? Sorry, it is just V by 1 ampere, so it is V. So in this circuit, if you look at which one will be easier, if you see, we want this IO value to be known. So if you connect a current source of 1 ampere, it will be difficult to find how much current goes into each of these nodes. So the simple thing to do is, put a voltage source of 1 volt here. Then the voltage across this 1 ohm becomes same 1 volt. So what will be I0 here? I0 here? I0 is nothing but 1 volt by 1 ohm, which is 1 ampere. So now you know I0. Your goal is to find this total current I. One of them you got it. So now let us try to find this one. So we know I0 value. So what will be 3 I0? This will be equal to 3 volt here because it's a voltage source. So the voltage across this resistor is 3 volt. So what will be the current here? So this current, let me call it as I1. I1 will be equal to 3 volt by 1 ohm, which is equal to 3 ampere. So 3 ampere is flowing here. Now we need to find this current. So where will this current go? So if you come here, it goes here. And here if you see, this is a short circuit and this is a 1 ohm. So this 1 ohm, no current flows. So we can even take this out. So this doesn't make a difference, right? So now what is this voltage? So we said this is a reference. So this was 1 volt and this is minus 3. So it is 1 minus 3, which is minus 2 volt here, right? So now if you see, minus 2 volt is seen across this 1 ohm resistor. So what will be this current? Let me call this as some I3. So I3 will be minus 2 by 1 ohm, which is equal to minus 2 ampere. So if you see here, minus 2 ampere is flowing, which means that in this direction 2 ampere is flowing, and here in this direction how much I1? 3 ampere is flowing. So what will be this current? In this direction it is 5 ampere. So this is 5 ampere, right? Let me call this as I2 in this direction. So what is your total current I here? Your I is nothing but, it is I1 plus I0 minus I2, right? So what is your I1? It is 3 plus 1 minus 5. So it is 4 minus 5, which is minus 1 ampere. So effectively 1 ampere is flowing into the voltage source, which means that our RTH is going to be negative. And what is the value of RTH? It is 1 by I, 1 by minus 1, which is minus 1 ohm. So your RTH negative is possible because of this dependent voltage source. If this network was only made of resistors, then this RTH should always be positive. But because we have a dependent voltage source, it can also be negative. In this case, it is negative. Also, while finding this I2, you should be careful that you should not substitute this entire 2 ampere is flowing through this. You should also make sure you also consider this current coming in. So although the circuit looks very simple and straightforward to solve, there are little small mistakes you can make. So you should be careful while solving such questions.